Okay, here we go. We are going to do our test review for Unit 14. To start us off, let us keep in mind what could you put on your formula sheet. Here are some pictures of the different things that I used to make up the formula sheet. I broke this up into 3 pictures, so pause as you need. But here is picture number 1. Here is picture number 2. Some things overlap. Pause as you need. And here is picture number 3. Boom! And there is the formula sheet that can help you. Add on as you need to. And there you go. But again, I will count this as points on the test. So make sure you have this done. Thank you so much. Now let's look at the problems. So here, like the first few questions, maybe we're talking about knowing parts of a circle so that way we can identify those and work with those. So like in this case, we're going to say name a chord. And a chord, remember, is a line segment with the endpoints on the circle. So like here I could say DE, or reverse it and say ED, or even AB. The diameter, remember, the diameter of a circle is also a chord. Okay, and then name a radius. PB, PA, or PC. Again, I prefer that the center be the first point, but if you switch the lettering around, I won't take off points for that. So keep that in mind. There you go. So those are your radii, or your radius. Radii. So if PC is 11 inches, what is the length of AB? So notice that PC is your radius, or a radius. And then I want you to find the diameter AB. So that would tell me then to find the diameter, again, go to your formula sheet, which you've already seen a picture of, and you would see that diameter is equal to 2 times the radius. So if I multiply this by 2, I get 22. If I went the other way around and gave you the diameter and asked you to find the radius, you're not exactly sure why, but it paused, so here we go. But again, you could divide by 2 if you want to go from the diameter back to the radius and get the answer from there. Okay, so the next part is going to be the diameters. Number 4, question log number 4, that will definitely be on the test. And just keep in mind, what does it mean to be 5 and 6 respectively? That means circle G is 6 units, circle F is 5 units. Also, the radius would be 3. And then I would say subtract the radius by the diameter of the other one to get the answer of 2. And pretty simple. Nothing too difficult. Trying to keep it pretty simplistic. Alright, so next question. Remember that the diameter and radius is equal to the circumference, and that the diameter is equal to the circumference divided by pi. The radius is the circumference divided by 2 pi, which should also be on your formula sheets. So if you put the 17.2 into those questions and say 17.2 divided by pi, you're going to get 5.47. If you say 17.2 divided by 2 pi, you'll get 2.74. Exact circumference. I expect to see an exact answer, not something else. Okay, so in this case, what I want to see is, okay, use, yes, Pythagorean Theorem, a squared plus b squared equals c squared to get the diameter. So you take the square root, you're going to get 17. That's going to represent the diameter. Then from there, with the diameter being 17, you go ahead and say, all right, the diameter times pi is the circumference. And there you go. So this one, the answer is 17 pi. And that's it. That's the exact answer. That's what I want to see. Okie dokie. Okay. And okay. We can do it. Okay, so this next part, make sure you know what's a minor arc, a major arc, and a semicircle. Again, it's in your formula sheet. Majors are greater than 180. Minors are less than 180. A semicircle equals 180. 2 letters is usually a minor. 3 letters can usually be a major, although either one can be a semicircle. So if you look at this, U to Q, and again, fill in all the degree measures before you start trying to find the answers. But here we could say 50, 90, 90, and go from there. Now, U to Q is a minor. We can see that, or Q to U, yeah, U to Q. And then that would be 40 plus 90, which would be 130. And that's your answer, 130 degrees. Q to U to S is a major, which would add 90 plus 40 plus 50 plus 40, which would add up to 220 degrees. And then, of course, Q to T is a semicircle, which is 180 degrees. Now, arc length. Arc length means take the degree of the arc, 50 degrees, over 360 times 2 times pi times r. Plug it in, come up with an answer. Keep in mind that if you got a diameter, you might want to change it to a radius and then do the same thing. So fairly simple. Don't overstress it. Make it easy. Okay? Don't try to overdo the problem. On a problem like number 12, keep in mind that like you're saying if the chords are congruent, the arcs are congruent. Conversely, if an arc is congruent, the chords are congruent. So you should be able to do that. So here you could say 4x plus 2 is equal to x plus 17. And again, if you don't do it by hand, I'll back this up a bit. If you don't do it by hand, it's going to be numerical solve, which you can see that in the top right corner of that third picture for the formula sheet. Menu 3.1, type in the equation, comma x, press enter, and it tells you x is equal to 5. If not, do it by hand, variables to the left, numbers to the right, and then you can divide. Very simple. It's really not that hard. You should be able to do that by now anyway. Either way, it should be a time saver. It shouldn't take you long to do that type of problem. Now, let me back this up a bit. Same idea here. Notice that the chords are equal, so that means then that x and x is x. So that if one arc is x, then the other arc is x. That gives me 2x is equal to 360, and then I can subtract, or 2x plus 38 equals 360. Then I can subtract and then divide by 2 to get an answer of 161. Okay, so when we see a problem like this, again, the idea is that, remember that that radius is bisecting the chord and the arc. So all you got to do there is divide by 2. So you divide those numbers by 2, and you would get that the arc is 35.5 with the chord being 30, length of 30. So just make sure that you're dividing by 2. Here, we're going to say because those two numbers are equal, those two lengths from U to L and U to M are equal, then VW and ZY are equal, so I can say 5x equal to 20. And then when I can do that, I can just simply solve and go from there. On 17 and 18, keep in mind that if you start at an inner angle, go to the arc, you will multiply by 2 and get 46. If you start at the outer arc and go inner, you will divide by 2 to get 81. Again, easy peasy, nothing difficult. Okay, so for this example, make sure that this is not on the review, so make sure you copy this somewhere else. But keep an idea that say right here, we're saying that these two arcs intersect, or these two angles, this one and this one, intersect at this arc. They have the same arc. So if that's the case, then that means they have the same angle. They're equal to each other, so 5x equals to 50, so x is equal to 10. So easy solve, nothing difficult. Alright, so the next example, we got to use Pythagorean Theorem. If you want to determine something is tangent, yes or no. Does a squared plus b squared equal c squared? Keep in mind that a is the radius, b is the line that we think is tangent, c is the line from the radius to the outside point. And number 20 is another variation of that where you actually solve for x. So again, you plug them in, type them out, and that should be fairly easy. Nothing super difficult there. Alright, number 21, again, notice that those are two lines that are tangent to the same point. So that means then they should be equal. You can do your numerical solve if you don't remember that. Numbers to variables to the left, numbers to the right, and then you can divide. On problems like 22, notice that the intersection happens on the inside. Okay, so this is an inside intersection. So that means you add them up and then take half. So angle 1 is half of 50 plus 56, which equals 53. Simple, right? Okay, next one. What happens like on 24? I'm going to go to 24, then back to 23. On 24, we have the intersection happening on the outside. So that means you subtract. You say 120 minus 40, and then take half of that. 120 minus 40 is 80, and then half of 80 is 40. That one happened on the outside. What happens if it's on? It is take half of the arc right there. So that x, which is the arc from R to V, like that, is going to be our answer. But first, how do we find the x? Well, if the 124 degrees is that other arc, I can subtract it from 360 to get 236. And then if I got 236, I can take half of that to get an answer of 118. Easy peasy, right? Okay. Number 25. I'm trying to go through these quickly. You can always pause me, whatever, and yeah, pause me, recopy, whatever. But the main idea is, again, make sure you set up your formula sheet. By the way, bonus word. Why can't we have a bonus word? Well, we should have a bonus word. So I'll put the bonus word is 1 plus, as in one word. Let's see if y'all remember that. Anyways, so here, when you have like this, intersections happen on the inside, you got to multiply. So 18 times x equal to 15 times 12. And again, that's 18x equals 180. Solve, you get x equals 10. On the other one, you need to add them first. So 13 plus 5 is 18. X plus 9 is x plus 9. And you say the outside times the inside. I'm sorry, outside times the sum. Outside times the sum. And then put it into the numerical solver if you don't know how to do that, and you should get an answer of 6. Alright, for circles, make sure you know your center and your radius. So like if you look at number 27, you have a center at 7, -3. You have a diameter at 18, so that means the radius is 9. So then you would plug it in. Again, always start off x minus, y minus, radius squared. So 7, -3, and 9, which would give me x minus 7 squared plus y plus 3 squared equals 81. And that would be your answer. Okay, number 28 says my center is at the origin and a radius of 7. Okay, keep in mind the origin is at 0, 0. So here, like if you set it up like this, plus y minus squared is equal to something squared, you could tell me that it is, say, x minus 0, y minus 0, 7 squared, and you can give it to me as x minus 0 squared plus y minus 0 squared equals 49, or you could just tell me x squared plus y squared equals 49. Okay, either one would be acceptable. Number 29, can you identify the center? So always kind of remember that when you're going from the parentheses to the point, think opposite. So that minus 3 is going to be like thought of as a positive 3, because it is. And the plus 4 would be thought of as a minus 4, and then I can take the square root to find the radius. And there you go. Now, 30 and 31, they will be on the test. So here's how I set it up. Okay, make sure your x's are together. 8x plus parentheses plus y squared minus 10y plus, close it, equals, I should have left myself more space. Alright, so how it works is, underneath this, we're going to write x squared plus y squared and go from there. So what we do is divide by 2. That will give me positive 4. And then I'm going to square 4 to get 16. And I would add that over here if it lets me. Okay. And then this one I'm going to divide by 2 also. And that gives me negative 5. And I would square that to get 25, which I would also add right here. So 25 plus 16 plus 8 should give me 49. There is my equation of my circle. What is my center? Again, think opposite. Opposite of positive 4 is negative 4. Opposite of negative 5 is positive 5. And then for the radius, take the square root. Take the square root of 49 to get 7. So, to do the same thing on 31. On 31, make sure, again, you put your x's together. So I'm going to say x squared minus 12x, close it. Notice I put a plus y squared minus 14y plus, close it, equals negative 4. Okay, so now I'm going to do this and say, alright, x squared plus y squared equals, and divide by 2 gives you negative 6. That's 36. So plus 36 over here. Divide by 2, negative 7. Square that is 49. So plus 49 here. Add those together and you should get 81. So then my center is at positive 6, positive 7, with a radius of 9. And with that, we are done. Good job, guys. Thank you so much for your time. Y'all been a fabulous audience. And go ahead and take care. Hopefully y'all do well with this test tomorrow. I will be so proud. Thank you so much. Y'all take care.